All right. Welcome to this lesson on the tangent ratio, our first lesson in the series of lessons on trigonometry ratios, okay? We'll be looking at a series of ratios, predominantly the three basic trig ratios, which are sine, cos, and tan. And I'm going to start with tan. You may have noticed these on your calculator if you look very closely. If you have a scientific calculator like this, I imagine many of you have, it has the buttons SIN, COS, and TAN. And tan is the one we're going to look at today. The other ones that we'll look at later are sine and cos, and they're pronounced sine and cos as opposed to sin and cos, which might be their phonetic pronunciation, but we in trigonometry call them sine and cos. Okay, so first we're going to look at the tangent ratio, and as you saw already, tangent is written in here, right there. It's also in the title, but the real words that we use are TAN. And I usually draw my T's with just a little hook on the bottom so it doesn't get mixed up with a plus sign. And that's our tan symbol, or tan is what we're going to call this. All right. So the best way for me is to sort of jump in and kind of explain what happens. And to do that, I need a right triangle. And remember, I cannot emphasize this enough that all trigonometry that we do in this course is based with doing it with a right triangle. And so the first thing I can do is I'm going to actually draw in the right triangle on this particular triangle that I'm using. And you'll notice that I have a nice triangle. I don't have a reference angle, so I'm going to set a reference angle. I'm going to say that this is my reference angle here, okay, theta. And once I do that, now I have the ability to label the rest of the triangle. So this will be opposite the right angle is, of course, my hypotenuse. Opposite the reference angle is the opposite angle, and alongside the reference angle is my adjacent, and that was from the previous lesson that you did to teach you how to do that. That's why we needed to do this, is we needed to be able to label these triangles correctly. Now, this gentleman, years and 1,000 years ago, discovered that when we looked at right triangles, if we took the opposite side and divided it by the adjacent side, for every triangle that had the same angle right here, the same value of the reference angle, we'll pick a value. Let's say that this is 30 degrees, okay? Then he found that if I took the opposite angle and divided it by the adjacent angle, it was always going to be the same value. And he called that tan 30. Okay, so that's tan 30 degrees, and that works out to be a set value. Okay, now what that value is can be looked up off of a table, or you can use your scientific calculator. Nowadays, kids really use a scientific calculator, but I also like to show kids that it can be done from a table as well. So here's an example of a set of tables. Here's the angle, okay, I'm over here. Here's our angle increasing up, because we could have a triangle with 1 degrees, and we can go all the way up and keep going. And I can scroll down, it goes all the way to 45 degrees, right? And we show all three ratios here: sine, cos, and tan. You don't know what sine and cos are yet, but let's just say it's tan that we're looking for. Tan is the third column at 30, and the answer is 0.5774. So we go back to our other by the way, this table that I'm showing you here, I've made it available for you so you can print a copy of it off. It's on your content section of the VLE, and I will email it out as well. Okay, so it is, what was that number? I'm just trying to remember, oops, didn't like me there, jumped on me. Sorry, I apologize. Sometimes I bump on the wrong spot, I think, and it goes ahead in the document on me. So let's just go back to where we were. 0.5774 is what I believe it is. Now, another way that I can find that value is simply use my calculator and push in. So I've turned it on, I push in the tan function, clear it here, tan, and then I put in 30. okay, and then I hit equals, and it tells me my answer is uh, 0.5735, which would round off to 4. Okay, so if you look, I don't know if you can see that on there, but I'm just showing that to you just to be fair. And so I can look it up on my calculator. All the calculator, tan, sine, and cos functions do is they look up these values that come from that table. You can just look them up off the table if you want as well, okay? So just to kind of better explain this, what happens is if I go here, I can actually see if I can get this to work for me. I could pretend that I have a bigger triangle. Okay, this is still 30 degrees here, and if I put my right angle in here, this now becomes my A. A is here, and O becomes here. This is like big O, A. I'm going to call it A1 and O1, and those are big values. And then H1 over here, these are the longer, bigger values. And if I take the big O here, the length of that side, and divide it by the length of this side here, if this is 30 degrees, I'm still going to get the exact same answer that I got right there, okay? 0.5774. That's the really cool thing about this, is that it doesn't matter what size that triangle is, this will always come out to the same value, okay? And it's kind of a unique feature, and we can use this, okay? Now, what they say is that they come up with an equation, and they say tan theta equals the opposite side over the adjacent side. And this here represents a ratio, okay? That's why it's sometimes referred to as trig ratios. The tan ratio is the opposite side divided by the adjacent side of a right triangle, okay? And we can use this information to sort of solve equations. And let's do some examples. And it kind of, as I do three different examples, you will sort of see how this works, okay? And I'll show you different ways of doing this, okay? Find the missing side or angle. Note all triangles are right triangles, okay? And this is just me repeating what I said up there. There's the equation right here, right, that we're going to use. The equation can be used to find sides and angles of any right triangle, okay? And I'll just erase this silly thing here. Whoops, that didn't work. There we go. And we're going to go down here and do an example, okay? So let's say we have a triangle like this, and I want to find x, okay? So the first thing I have to do is identify my reference angle. Well, this is my reference angle. It's 60 degrees. So this is kind of like theta. And now I can label my sides. Now I don't need to worry about it so much, but it's always a good idea. This is my first step, always. Always label the reference angle, label the sides. Step one in these, okay? So H right here. Then I get opposite over here. And this here, my x value, which is kind of ugly there. Maybe I'll clean them up a little bit. Clean up my x a little bit here. That looks like a little better x, okay? And is my adjacent side. Now, what I'm going to do is step two is I'm going to write down my appropriate ratio. Now, because this guy's out of the equation, I'm not asked to find anything with the hypotenuse, and I don't have a value given there. I only have A and O. So I want my tan ratio, and all the questions in this lesson will be on the tan ratio. As we add other ratios, you'll see that we can do the hypotenuse as well. So in this particular question, I'm going to write my equation, which is tan theta equals the opposite over the adjacent. And you have seen me ask you to do this before. This is going to get you a mark. You're going to get a mark for putting these labels of A, O, and H on. You get a mark for this. And now what we do is we substitute in wherever values we have. So do we have a value for theta? Sure do. We have 60. So it's tan 60 equals opposite 2 over adjacent, which is x. So I put in x here. Now I need to solve this. Okay. Now, there's a couple things. I'm going to show you a couple little tricks here. Okay. First of all, what I'm going to do is I'm going to find the value of tan 60. Let's put it in there. And I always write this to 4 decimal places. Now I can do this in 2 different ways. I can go to that table that I talked about, tan 60. Let's look at this. Tangents are here. This is the angle, 60. Tan 60 comes across, is right there, 1.7321. Okay, so I can write this in as, go back to my question here, and I can say gotta get my pen back on, 1.7321 equals 2 divided by x. That wasn't that hard. How else could I have done it? I can do tan 60 in my calculator, right? I can just write tan, type in, cleared my calculator, tan 60 equals. Now be careful, some calculators actually require you to go 60 and then put tan. So you have to know what yours is, okay? So in my case, I'm going to do this, tan 60 equals, and the answer is 1.7321, just the exact same as I've already got there. Now, there's a little trick here. Whenever you have your x on the bottom, it's just a trick I'm gonna teach you. You can switch these two. It's kind of cool, but it's just the way it works, is that you can actually switch these two, trade places. It's kind of a neat little trick, and I sometimes explain this using the 12 thing. As if I say 4 equals 12 over 3, right? 12 divided by 3 equals 4. What does 3 equal with respect to this? Well, it equals 12 divided by 4. What did we do? We just traded places. And this, believe it or not, this works all the time. So when I have x on the bottom and I want to know what x is, I just trade places with it. So I say x equals 2 divided by 1.7321. It's a little mathematical trick that you can follow. Now I can simply put those numbers into my calculator, clear my calculator, and do 2 divided by 1.7321, and I get an answer. And the answer is 1.15. Now, I always round it off to the nearest 1 decimal place when it's a side. So in this case, x equals 1.15, but I'm going to write it as 1.2. And then I'm going to put my answer in, and I'm going to include units. So x really equals 1.2, and I add my units. It's really important that I do that. And I like it when kids do this. I love it when they put a box around their final answer, because I can kind of really quickly mark it and say, oh, yep, they did that. Oh, and they got the right answer. Everything's good. And away we go. Okay. Now I'm going to show you another technique that you can use along the way that just kind of saves some time, okay? So just going to erase this stuff over here so I have a little extra room, okay? And I'm going to show you another technique, and this is probably how most kids who are doing higher level math do it, is what they do is they get to this point right here, this step, and I'm just going to write this over here, and they write, I'm going to rewrite this. I'll go tan 60 equals 2 over x. And what they're going to do is they're going to trade places. They're going to trade tan 60 with x. And what they know is that tan 60 is just a number. It's very simple. They're going to go x equals 2 over tan 60. And then they're going to solve with their calculator for this value, okay? So I didn't write my 60 very well there, but trust me, that's a 60. And I'm going to simply go like this. I'm going to clear my calculator. I'm going to put in 2 divided by, and then I hit tan 60, and I say equals. And guess what? My calculator gives me an answer, and it's the exact same answer as over here that was calculated before. It's 1.154, which really works out, and I round it off right away, 1.2 meters, and I'm all done. So you can eliminate some of these steps. You don't have to look things up in your table. All this stuff, you can do it there. Now, I can also show you this using the calculator that comes with this computer. Watch this, okay? So if I want, the only time I needed to use the calculator is when I get here, 2 divided by tan 60. So I can go 2 divided by, and there's this little button here that says trig. So I go trig tan. No, that didn't work. This one's a little trickier. Let me see if I can get this to work. I think I have to go 60 tan. Okay, so I might not be able to do it because these calculators are pretty rudimental. So see if I can do this. 2 divided by trig tan. No, it's not going to let me do this. I'm going to have to actually calculate tan 60 separately. Let me, oh, I canceled that. Sorry, I apologize. Calculator. Let's open it up again. I'm going to have to do the tan 60, but I can here. I can go 60. I have to type in 60, 6, 0, and then go tan to get this to work, unfortunately. And there it gives me the 1.732. And then I would have to write this step down and then do the calculation with this calculator. It's a little more slow. Most scientific calculators can do it the way I just said it, and it's much easier, okay? So if you have a good quality Casio or Texas Instrument scientific calculator, it really, really helps you. And I'm going to be honest, I recommend that right from the beginning of the course, and part of the reason is for this trigonometry. All right, let's go on and try another one. I'm going to avoid using the computer calculator because it's just so cheap. All right, so here's a new one. Let's try this one. First step, label, right, the sides and label the reference angles. So this is our theta, this is our opposite, and this is our adjacent. We won't, oh, this is my right angle, but we won't need this over here, right? We don't need the hypotenuse. This has opposite and adjacent. So I write my equation down. Tan theta equals O over A. And now I'm going to start substituting in. Okay, substituting in, I'm going to get tan 36 equals 14 over x. Opposite over adjacent, okay? And in this particular case, now, again, I can switch. I can just do the traderoos, okay? So I can say x equals 14 over tan 36. Now, if you have a scientific calculator, you're in good shape. You're in really good shape. You don't have to do anything. If you don't, you're going to have to look up tan 36, okay? Now, you can do that with the calculator on the computer, right? Or we can use this table, right? 36 tan. Well, I'm looking for the angle of 36 right here. There's 36. This is sine. This is cos. Tan. 7265, 0.7265. So remember that, 7265. That's easy for me to remember, 72 and 65. That's my wife and my birth years. Amazing, eh? So now I can say x equals 14 over 0. Oh, why does it do that to me? Scroll down. It doesn't like me sometimes. 0, I'm going to erase this down here. Do a little cleanup. 0.7265. And now it's just a matter of dividing 14 by that amount, okay? I can go 14 divided by 0.7265, and it equals 19.27, which is going to round up to 19.3, okay? And that will be in meters, and I'll put my X there, and I have my answer right there. Okay. Sometimes kids will write it over here as well. They'll write 19.3 meters. Okay. Now, to be honest, when I'm at this step right here, right, I'm just going to scroll back up a little bit, see the whole solution. When I'm at this step right here, if you have a good scientific calculator, you can simply put in 14 divided by tan 36, and you have your answer, and the answer comes out to the exact same thing, 19.62, and you round it off to 19.3, sorry, 19.26 rounds off to 19.3, okay? All right, so it works really quite nice. I'll just clean off this, and now I'm going to do one more example. Maybe I'll do a couple more examples. We'll see. It's good to do examples, right? Let's do this example here. This time, the question does not have an angle, but it has two sides. So once again, same thing. I already labeled this as theta. That means this here is my opposite. This is my opposite, and this is my adjacent. Same thing. Tan theta equals opposite over adjacent, okay? And in this particular case, I substitute in my values, and I go tan theta equals 2 over 3. And I can, oh, sorry, I apologize. Correction. Let's correct that. The opposite is 3, so it's 3 over 2. 3 over 2. And I can divide this. What is 3 divided by 2? Well, that equals 1.5. So my tan theta equals 1.5. I want to figure out what the angle is if the ratio is 1.5. Well, we can go back to our table. Okay, back to our table. And this time, what I'm going to do is I'm going to look in the tan column for 1.5. And you'll see here, as I go through, you can see here, I'm going to scroll along. Okay, 0.016. Look at it, it's getting bigger. Tan's getting bigger. It's not scrolling very nicely for me, so I'm going to... Tan's getting bigger. It's up to 0.5. Okay. Oh, boy. Oh, sorry, I apologize. Trying to use the pen and my finger at the same time. It's just not working. So look down the column here, the third column, and you'll see the number goes up. 45 goes to 1. And then I have to come back up to the top. And now look at over here. I'm going to use my pen, circle right here. Look at it's increasing. Oh, where's 1.5? Oh, it's right in here. It's between 56 and 57. Now this is where it's always tricky. Which one is it? Which is it closer to 56 or is it closer to 55? Well, if I have 1.5 and this is 1.539 and that's 1.4826, it's actually closer to 56. You have to pick. Okay, and if you get it wrong, I'm not going to freak out because you're out by 1 degree and I'm going to give it to you. But the answer here would be 56 degrees. Okay, so if we go back to the other question, I now say, therefore, theta. Oh, why does it do this to me all the time? It doesn't like me. I don't understand these programs. Okay, theta equals 56 degrees, and That's right here. And now I could write that 56 degrees right in here as well. Okay. Now you can also use your scientific calculator to do this. Now, this time you need to do it in using it like this. You need to do a shift or second function, whichever one on your calculator works for you. In this case, I use shift tan. Okay. And so what I do is I go shift tan, and then I put in the number 1.5 and I say equals, and it comes out to 56.3, which rounds off to 56 degrees. I just want you to get it to the closest degree. I don't really care if you get decimal degrees, just to the nearest degree is fine, okay? And I have then solved the answer to that question, okay? Not a problem. Okay, let's do one more. I'm going to do one more. I didn't put it down here. See if we can create. Well, let's go back up here and let's just erase this. I'm going to erase this and pretend. I'm going to completely erase the whole question. Watch this. Bear with me. This beautiful eraser, right? This time, I'm going to change things up, and I'm going to put the x over here and the value here. I'm going to say the 14 meters should have been here. Same thing. This is the opposite. This is the adjacent. Okay, so I solve it the same way. Tan theta equals the opposite over adjacent. And then I start substituting in. Tan 36 for theta equals x for opposite over top of 14 for the adjacent. And in this particular case, it's a little different. X is now going to equal tan 36 times 14. So we're going to multiply them. I don't need to switch these two x's on the top. I just need to multiply these two together. Think of it this way. If I multiply this side by 14 and this side by 14, these two cancel to give me 1. And I'm left with x equals this. So x equals 14 times tan 36. And that really is an easier calculation than what we were doing before. I can do this by looking up tan 36 again, which I believe was 14 times 0.7265, and that's what x equals. Or I can use my trusty calculator and simply go, either way, it's going to come out to the exact same answer, 14 times tan 36. And the calculator will look up tan 36, substitute in this number, multiply it by the 14, and it gives me the answer x equals 10.17, which I'm going to round off to 10.2. I'm going to put meters on there, and I box this. And so the actual answer is 10.2 meters, which I can write over here if I want as well. Okay, so that's just yet one more example. I didn't draw that on the sheet. I probably should have done it that way, but I didn't, and gives you an example where you have to find it when it's the opposite. There's a nice worksheet, gives you a bunch of questions to solve for opposite and adjacent, as well as some for the angle. The answers are provided below, so enjoy that worksheet.